We're doing maybe a little extra, although I think sometimes the honors class covers this piece, and the extra that we're doing is looking at domain, okay, for our combinations of functions. So one thing we want to talk about real quick here at the beginning is a new notation. So this one is basically what I would call in Algebra 2, you probably had a section that was just called function operations. And operations in math are things like add, subtract, multiply, divide. So this is the sum, difference, product, and quotient of functions. So they're the four basic function operations that you can do. And you can take different types of functions. You can take 2 functions, you can take 3 functions. You can combine them through these operations. So you can add, subtract, multiply, and divide. The pre-calculus textbook does use a new notation, which is what you're seeing up there on the board. That's probably not how you wrote it in Algebra 2. So I just want to clear up so that everybody, when they see this notation, they know what it means. F plus g of x is the same thing as f of x plus g of x. So it really just says, like, you've got a function f, you've got a function g, add them together. The things on the left don't mean anything like add f and g and then multiply by x. That's still function notation, so it doesn't have any extra piece. It's just a different way to write it. So you could fill in all of these now. This is f of x minus g of x. This is f of x times g of x. And this is f of x divided by g of x. Now, in order for you to be able to add, subtract, multiply, divide, the 2 functions have to have some overlapping domain. So they have to have some x's in common so that you can add, subtract, multiply, and divide. When you actually do that add, subtract, multiply, and divide, that may change your domain, okay, or your domain may remain the same. One function that you have to be really careful of is division. What's always your trouble with a fraction? What are you not allowed to do? What's that? Well, you can divide fractions. Yeah, Maggie? Okay, we're not going to cancel out x's if they're not factors. In division, what are you not allowed to divide by? 0. So always with a fraction, a numerator and a denominator, you run into this issue. These are the rational functions you studied at the end of the year. Your denominator can never equal 0. So this one usually comes with like an extra statement where g of x is not equal to 0. So you just make that statement because it's division. I'm going to give you 2 functions on the next slide, and I'm just going to let you loose with your small groups. You guys do the 4 function operations. I am positive that you are skilled. There are a couple of things you'll have to be careful of, so it's a good idea to kind of talk to and compare your answers with your group members. And make sure you agree. But I'm giving you f of x is 5x plus 2. G of x is 3x minus 4. If you would, for me, add, subtract, multiply, and divide those functions. And like I said, feel free to talk to your group members, check your answers, bounce ideas off of each other if you're at a loss. Okay, so there are some good discussions happening out there. Take a minute and look up. I've got my answers on the screen. Did those real quick. Are there any that we have questions about or disagree with?
Is that it for the division one?
Mm-hmm. Yeah, in this particular division problem, that's a good discussion I heard among some groups. Like, I really don't know what to do once I get there, right? The one thing you could try is to factor the numerator, factor the denominator. If they were to share a common factor, you could then reduce it by that factor, just like you would normally do with a fraction. But there's no factor for 5x plus 2 that I could take out of both terms, same for 3x minus 4. You are not allowed to simplify 2 over 4 and make that 1 over 2, because those are not factors, those are terms. 2 is a term in the binomial 5x plus 2. It's not a factor of that binomial. So whenever there's a plus or a minus sign, you cannot just cancel the factors or cancel the numbers. Same thing for the x. Can't just cancel that x. So yeah, on that one, there's nothing else to do. What's another tip that you might give to like a newbie to function operations? Which one of these can be tricky sometimes? Subtraction. Who said that, Elise? Why subtraction?
Because the negative goes to both the 3x and negative.
Yeah, so you'll notice in my notation, I protect all my functions with a set of parentheses. In addition, it's not really necessary to have the parentheses. It doesn't matter because I'm just going to end up combining like terms. But in subtraction, it makes a difference. You want to subtract all of g of x. To say all of g of x, you should have a set of parentheses. And then like Elise said, we're going to distribute that negative, and it's going to change the signs of both terms. So maybe make a mental note to yourself if that's something that you often find yourself tripping up on. So kind of be aware of that. One final thing that we're going to say about these is we could talk about domains. Okay, so I'm going to go back to f of x and g of x. What type of functions are those? Linear functions. What's the domain for a linear function? All real numbers. Okay, so I'm going to just mark this domain is negative infinity to infinity, and this domain is negative infinity to infinity. So they actually overlap everywhere. Now I want to look at my new functions I've created and list their domains as well. So when you add the functions, you get a new linear function. Domain is still all real numbers, negative infinity to infinity. Same for subtraction. What type of function is my product? Quadratic. What's the domain for quadratic? Still all real numbers. You can put anything you want in. So I'm still all real numbers, negative infinity to infinity. And then I get down to quotient. Can I put anything I want in? Almost, right? What's my one trouble spot? 0 in the denominator. How will I figure out what x doesn't work? Whatever makes it equal to 0. So what I do is I take whatever my denominator is, 3x minus 4, set it equal to 0 and solve. So 3x equals 4, x equals 4/3. That's the one thing it can't be. So my domain would be negative infinity to 4/3 exclusive, use the parentheses, in union with 4/3 to positive infinity. So it's just skipping over 4/3, but everything else works. So it's not always 0 that doesn't work. It's whatever makes that denominator equal 0. So you might have to solve the denominator. Okay, good. Okay, we want to talk about one more thing before we leave today, and that is compositions. So we'll just go ahead and define compositions quickly here. And this is kind of similar to what we were looking at in the warm-up on that last one that was similar to your summer packet. A composition is different than adding, subtracting, multiplying, and dividing. It's not one of the basic 4 operations. A composition is basically substitution. there is a new notation that the pre-calculus textbook will use. It's this open circle, but you still read it the same way, f of g of x. You can use your old notation from Algebra 2, which is a set of parentheses, if you prefer that. Either one is fine. Just be aware of, you're going to see that open circle in the textbook. You need to be able to use that as a composition. Substitute one function in for x in another. The domain of the composition is the set of all x in the domain of G, such that g of x is also in the domain of the new function, f of g of x. So this is my new function, and g of x is my inside function. So sometimes you have a bigger domain for G, and then when you start doing compositions, your domain gets smaller and smaller because of whatever the functions are. Other times, G is a function that has some kind of restrictions, and then even though your new function has a bigger domain, because G was what you had to start with, it was your inside function, it limits everything else. So we'll look at an example so we can see that happening. I'm going to do this example first. We're going to let f of x be equal to x squared minus 9. And we'll let f or g of x be equal to the square root of 9 minus x squared. We're going to do two things for this example. We're going to find their composition. We're going to substitute one function in for x in another. And then we're going to find their domain. I'll use the new notation. Sometimes it looks like you're writing the word Bob. F of g of x. And the second letter is always your inside function. So that's the function that you want to plug into the other function. So we're going to use x squared minus 9 as our outside function. We're going to replace this x right here with the function g of x. Okay, so it will be the square root of 9 minus x squared, that's g of x, and we're subbing that in for x, squared minus 9. No. This is not a property of radicals. The properties of radicals only work for multiplication and division. You can split them up and do them individually. But my best example is this. The square root of 9 plus 4. You're telling me the square root of 9 plus 4 is equal to the square root of 9 plus the square root of 4. That would be 3 plus 2, which is 5. This side is really the square root of 13. Is the square root of 13 equal to 5? So that's not a thing that you can do. So no simplifying needs to be done in G. Just sub it in. What does simplify, though, once we sub it in? The square root and the square will cancel each other out. That is allowed. So it's going to cancel out the square root, and then we're left with 9 minus x squared minus 9. And then we get negative x squared. Cool. Okay, so now we want to go back and we want to find the domain of the composition. When we look at the composition as is, it looks like a quadratic. So we'd be inclined to say the domain is all real numbers, negative infinity to positive infinity. But remember that in order for that to work, we really need to check the domain of the functions that we plugged into. So let's go back to our inside function g. Can you put all real numbers in for x and get answers back out? No. What are numbers that work or numbers that don't work there? Give me an example or a counterexample. Maggie. Oh, what is the square root of 0? 0. So does 3 work? Yes. But that's an interesting point, right? The square root of 0. Can you do things that are more than the square root of 0? Yeah, square root of 1, square root of 2, those things are else. Can you do things that are less than 0? No, because you can't take square roots of negatives. So 3 is going to be a boundary here on this domain. What's on the other side of that boundary? Zach?
Negative 3.
Negative 3. Those are the two things that give us 9 right there, and then 9 minus 9 is going to be 0. That's as low as we could go. So the domain for this function is anything between negative 3 and 3 inclusive. We can take square roots of 0. It's 0. But if we were to put 4 in, we'd start getting negative numbers out, and that's not going to work. Or even 3.1. And we can't take square roots of negatives. You would do 9 minus something more than 9. So now we know that really in order to be able to do this function, negative x squared, originally we had to plug into g of x. So even though this equation looks like it should have a domain of all real numbers, we would say its domain is negative 3 to 3. It's restricted by the very first function that you had to plug into. Does that make sense? Do you have questions about that? Yes, you.
I can do it.
Okay, can you give me another number that works or doesn't work? Do you know why some work and some don't? Yeah? Does 0 work? 9 minus 0 squared? Can you do the square root of 9? Yeah. Does 1 work? 9 minus 1 squared? Can you do the square root of 8? Yeah. Does 2 work? 9 minus 2 squared? Yeah, 5. Does 4 work? 9 minus 16. Negative 7. Square root of negative 7. Imaginary. So once you hit 3, 3 is the one that gives you 0, and you can't go any less than 0. So 3 and negative 3 give us that 9 there, and then nothing else works. Good. You do have a homework assignment from the textbook. On page 81. And you also have the problem set. So we have just a few minutes left, 3 minutes or so. If you haven't already taken an opportunity to look at that sheet that has the to-do list for your problem set, maybe glance that over now. Okay, so those are some things that you can do to make sure you're getting all your points. One of them that would be really important for this particular assignment is if you're doing like domain, range, increasing, decreasing, those things should be written in interval notation. So be aware of that. Also, show all of your work. I tried to talk about that in yesterday's warm-up with even, odd, or neither. You can't just write even and draw a picture. I'm going to want to see the algebraic work because that's what the directions ask for. Okay, so kind of be aware of that. Problem set is due tomorrow. That's the white sheet with the homework problems. Quiz corrections are due on Friday. Some people have turned them in. That's okay. We're going to do function aerobics on Friday as well. Hopefully the weather will cooperate and we can go outside. Dress appropriately. I would not wear this dress because I cannot do any aerobics in it. I'm restricted. So wear something that you can move around in. And then the chapter 1 test, just to clarify, is next Tuesday. That is the wrong date on your gold sheet. Should be 8/29.